Who's ever lived in a house for a long time? How important is touch-up paint to have? Super important. You gotta have it all the time, right? Like you slam something, you know, and then all of a sudden you have this big red mark along the wall. You gotta touch it up. Well, you don't have to touch it up, but eventually you gotta touch it up. Right, so having extra paint is a good thing, right? Good to have extra paint. Definitely it's better to have, it's definitely better than going and running out. You know, it's much worse to like be in the middle of it. You're covered in paint. You've got some paint on your shoes. You got paint all over. You got your things covering all the floor, and all of a sudden you ran out of paint, and you got like this patch left. Right? So you can either go buy a painting that matches that patch, or you can, you know, run out and, you know, have to change your clothes and everything else, and go out and get another bit of paint to finish it up. So it's so much better to have more than, you know, have extra. It's an American thing, right? Having too much. Go ahead.
And also, there's many places that accept paint that you don't need anymore, like Firehouse Station will accept extra paint for their sets. So there's a lot of high schools when they run production.
Perfect. Oh yeah, that's brilliant, right? Because yeah, there's a lot of good places you can always donate paint.
You can even donate it to like just cities so they can like touch up on curbs.
Good deal. Very nice. Okay, all right. Do you yourself advise to often recommend buying extra paint? Oh, we talked about that already. Yeah, so we kind of answered those questions, right? Why do they recommend you do that? So you have touch-up paint?
Because you may not be able to find the exact color.
Yeah. You find the exact color later, and then if you buy too much paint, yes. If you buy paint you don't use, if it's unopened you can return it, and if not you can donate it. Right? If it's unopened and it's unmixed, you can totally return it. All right. Good. So now we're going to focus on our last handout of the day. Yeah. Exact color later. Yes, return or donate.
No.
May not be able to find the exact color later.
No, above that.
Oh, you touch-up paint. You don't have to copy down my words exactly. That's okay. Yeah. You can always watch the video and just take stuff from there. Totally fine too. All right, so we're going to take a look at this next one here. Negative exponents in scientific notation. Our purpose, exponents are used in many formulas, especially in sciences, where exponents are used to write. Okay, so here's the thing about sciences. Scientists have really, really, really small things to deal with, and often they have really, really big things to deal with. And in order to compare things easily, you know, different things are really big or really small, what they do is they put into scientific notation. That way they can focus just on the exponent part, and that kind of tells them kind of a sense of how much bigger or smaller two things are to each other. So scientific notation is where you make your first non-zero number, you put that into the ones place, and then all the rest are decimals. So then everything you're comparing, if they have the same exponent, they'll be within a factor of 10 of each other. So we'll talk about what that means in a second. But you'll need your phone. We're going to go through some of these All right, so first of all, some rules. What's the meaning of x to the negative n? All right, let's talk a little bit about exponents. Let's talk a little bit. Yeah, you're good. So a little bit about exponents. So first of all, if I have x to the third, what does that mean?
X times X times X.
Yeah, x times x times x. Remember, multiplication always starts with what? An invisible 1, always. Because multiplication always centers around 1. Addition always centers around what?
0.
0. Okay, so multiplication always centers around 1. So it's 1 times x to the third multiplied by 3 x's. X, x, x. Good? X to the second is, again, start with 1, and it's multiplied by 2 x's. Good? X to the 1 power, sometimes we just write x. That's really 1 times 1x. Yeah? What about x to the 0? Ooh, this is where it gets tricky. What's x to the 0? Yeah, I start with 1, and I multiply by no x's. I just don't multiply by anything at all. Does that make sense? So, if you remember this trick, the fact that multiplication always starts with 1, then you'll remember that x to the 0 is 1, and not make that mistake of thinking it's something else, which we're not even going to say, because I don't want to confuse people. Good? X to the any number to the 0 power is just 1. That means you start with 1 and you multiply by nothing. Alright, so now it gets a little tricky. X to the negative 1. Alright, so I have my 1. Negative 1. What's the opposite of multiplying? Dividing. So x to the negative 1 means we're going to do the opposite of multiplying by an x. We're going to divide by an x. Does that make sense? So it's 1 divided by x. X to the negative 2 is going to be what? Start with 1. Divide by x twice. Right, so it ends up like this. Oops, sorry. 1 over x squared. Good? A couple interesting things about this to note. One thing that's kind of interesting and useful is that if you have a negative exponent, it just means dividing by that many. So you can just put it 1 over it, and then you got the same thing. So it's kind of cool and useful. It also means that if I have, for example, x to the third over x to the fifth, that's really 3 x's on top, 5 x's on the bottom. Don't forget there's an invisible 1 here and here. So then these guys, 1 over 1 is just, x over x is just another form of 1. Right? Because x, 3 over 3, what's 3 over 3?
1.
What's 2 over 2? What's a million over a million? Right, what's 5 over 5? 1. What's x over x?
1.
Right, so any number over itself is just 1. So those go away, because they're just another form of 1. You multiply by 1, right, we learned that last class. Anything multiplied by 1 is just itself. So that is just 1, this is just 1, this is another 1. So what am I left with? I'm left with 1 on top, because don't forget there's always that hidden 1, and then 2 x's on the bottom. Good? So that's some of the nice things about, when they're the same base, you can just kind of cancel them out a little bit. Okay. So those are some basic things we need to know. And that's kind of all they're saying here. Is if you have x to the third over x to the fifth, really a bunch of these guys cancel out, and that's really what you end up getting. I was just kind of stepping you guys through it a little bit. Okay. So what's the effect of having a negative exponent? X to the negative n. That means you're dividing by n. You're dividing by x that many times. Does that make sense? You're dividing x to the n. Does that make sense? So in other words, this is equal to x to the negative n is equal to 1 over x to the n. Does a negative exponent, does a negative exponent make the value negative? In other words, is 3 to the negative 2, does that make it, is that negative? Is that a negative number? What is that? 3 to the negative 2 means what? It's the same thing as 1 over 3 to the second. What's 3 to the second? 9. So it's the same thing as 1 over 9. So the negative exponent does not make your result negative. What it means is you divide. Does that make sense?
So how did you come out with that?
Okay? So remember, a negative exponent means that instead of multiplying by 3, I'm going to divide by 3 twice. Do you see that, this part here?
I just don't know how you got negative to positive.
I didn't. The negative exponent means divide.
So what are you dividing?
Negative exponent means divide by this that many times. So negative x to the negative 2 means divide by x twice. X to the negative 1 means divide by x once. That's what negative exponent is. So I'm telling you guys, a negative exponent means divide by. That's what it means. It does not mean the number's negative. It means you divide by.
How did you come up with the answer on it? Because this is a different problem now, so I'm totally confused.
Okay, so anytime you have a negative exponent, it means you divide by whatever this is that many times. So this means divide by x 2 times because it's a negative 2. So if it's So if it's 3 to the negative 2, that means that's the same thing. Okay, let's do this. Let's do this. I often do this. So 3 to the third means what?
3 times 3 times
1 starts with 1
3.
times 3 times 3 times 3. Good?
Okay.
3 to the second means start with 1, multiply by 3 twice. Good?
Okay.
What's 3 to the 1? Start with 1, multiply by 3 once.
3.
Right, yeah, so it's just 3. What's 3 to the 0? Anybody? What's 3 to the 0?
1.
1. I start with 1, I multiply by no 3's at all. I multiply by nothing at all. Okay, so that's 3 to the negative 1. I take 1 and when I raise to a positive power, it means I multiply. If I raise to a negative power, that means I divide. I take 1 and I divide by 3. That's what a negative exponent means.
1 divided by 3.
It means I do the opposite of multiply, I divide. Instead of multiplying, I divide.
So it's 0.333333?
It's 1/3, yeah. Yep, what's 1/3? 0.33333.
Okay.
What's 3 to the negative 2? I divide by 3 twice, right? Multiply by 3 times 3. So it's 1 over 3 squared. What's 3 squared? 9? Yep, 1 over 9. Good? 0.11111. Good? Is that making sense to folks? Have you convinced yourself of this now?
No, not really. So when I did 1 divided by 3 divided by 3, you come up with something completely different.
Do you get 11111?
I got 1 divided by 3 divided by
Times
3.
1 divided by 3 times.
Yeah, 1, 1, 1, 1.
Yeah. What's 1/9? Do 1/9. 1 divided by 9.
1.
No, 1 divided by 9.
Oh, same thing.
Yeah? See? All right, so Does the value of the, so one thing I want you guys to realize is having a negative exponent does not make your, the expression negative. It means you divide. Does that make sense? It means you divide. This is a no. Negative exponent means divide. That's what it means. Complete the table below. So what's 10 to the third? I want to find 10 to the third in your thing. 10, 1 times 10 times 10 times 10. Well, multiplied by 10 is super easy. I just add a 0 to the end. Right? I have 10 to the third. That means I have 3 zeros. 1, 0, 0, 0. 10 to the second. 10 times 10 is what? 100. So second means 2 zeros. 10 to the third. Or sorry, 10 to the 1. 1 0. 10 to the 0 means I have a 1 and I have 0 zeros. I have no zeros. It's just 1. So powers of 10 are super cool because they're super easy. It just says, yeah, add that many zeros. Right? Super, super straightforward. Do you see that pattern kind of as we compute these powers of 10? Cool. Do you know where the, all right, so now compute some powers of 10. So get out your calculators and compute these ones. And remember, this is 1 divided by a 10, right? This is 1 divided by 2 tens. Do you know what the copies are? Oh, did you want security the other day? Here's us. I can actually open the, here's the 1600 building. Right here. You kind of go up these stairs here, and it's going to pop you up right here. Here's the name there. And then go up to 2400. You know that. As you're going along this path, so you're going to come up there, and then come up here. There's this little tiny weird-shaped building. Right there is the copy center. I'm going to have some copies, and they're not very many, like 50 pages. You can do that.
So they're actually there.
Yeah, just say Ms. Young wants me to pick up some stuff and he'll get me shit.
Okay.
I think that would be good. Okay, thank you. Alright, so 1 divided by 10. If I take 1 divided by 10, you guys got 0.1. Yeah? Alright, so find the rest of them. I do want to you see the decimal. I want you guys to see the decimal places. So you do want to calculate them, you'll see the decimal places, and you'll see like a pattern emerging from the decimals.
Can I do that?
Yep. Oh, this one's not right. So 1, oh sorry, divided by, what's 10 in a second? It's 100, right? Divided by 100? Yep, got that in. Okay, so what you guys should have is, James, what'd you get for 10 to the negative 2?
1 over 100.
Yep, but when you divide that, what do you get for a decimal? I want you to see the decimal thing. So get out your calculator and divide it. See a pattern.
0.01.
Yep. Next one, Alex, what'd you get?
0.001.
Ryan, what did you get for the last one?
0.0001.
Yep. So what you'll see, as you get to these larger and larger negative ones, is that the one just moves over, right? So you guys see the pattern? Similar pattern going on with that one.
So you just count the number of the exponents, put the zeros in. and-
Yeah. Oh, right, so here's a cool thing. So this is what one of my students, my stat students pointed out. She said, what you do is if you have 10 to the negative 4, you just have your number. So say it's 3.471 times 10 to the negative 4. She said you add 4 zeros to the beginning of it, because it's 10 to the negative 4. You add 4 zeros, 1, 2, 3, 4, and decimal place goes after the first zero. So this is really the same thing as 0.0003471. See that? Yeah, well, yeah, because it comes up in statistics a lot. So she was saying that's the cool thing, is if you have something like that, you'll get a lot in your calculators in statistics, E, -4 or whatever. That tells you how many zeros to add to the beginning, and this place goes after the first one, after the first zero.
But isn't E the same as 10? No.
E, yeah, it's an E. Cool. All right, so everyone kind of sees the pattern, I think. Excellent. All right, so now we're going to kind of compare relative sizes of astronomical objects. So here, Earth is 5,970,000,000 trillion metric tons. Huge, right? By comparison, Jupiter is 1,898,000,000,000 metric tons. To me, those just both look really big. I can't compare them. But let's put each of them in scientific notation. So everyone put them into scientific notation. In other words, Earth is going to be 5.970 times 10 to the something. 10 to the, I don't know what, negative what. How many decimal places are you going to move it over? That's what you have to count. Count how many decimal places you move over to get the decimal place between the 5 and the 9.
It's going to be negative exponent?
Yeah, because you're making it, oh, sorry, it's going to be positive. I'm sorry.
Okay.
It's going to be I'm sorry. It's really big, so it's going to be positive. My bad. So it looks like we're going to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 10 to the 12, yeah? So that's how many times I moved it over. Yeah, I did the same thing with Jupiter.
12. I think it's only 9.
No.
Aren't you supposed to add on the trillion at the end?
Oh yeah, trillion, sorry.
So it's another.
Trill. But don't worry about the trill because they're both trills.
Oh, okay.
Yeah.
Oh, you can do it like that.
Yeah.
So you move the decimal all the way, or not just to the 0, you move it all the way to the first digit.
You want the first, scientific notation, the first digit you move it over so that the decimal place goes after the first digit.
Oh, okay.
Yep, that's scientific notation. So everybody do Jupiter now. Do Jupiter. It should be 1.898 times something. How many times should I do this? Because I need to get to that. All right, so I'm gonna move these over. Jupiter. Gonna be 1.898 times 10 to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 trillion. So, if I'm a scientist, right away I can say, well, these guys are never going to be more than like, factor of like 8 or 9 apart, really, at the most. So really it's here where you see the difference. Right? 10 to the 12th versus 10 to the 15th. Do you guys see that? That's 10 to the 3rd difference. That's 1,000 times difference. That means Jupiter is roughly 1,000 times bigger than we are. That's huge. So that's why scientists like scientific notation. They can right away see, oh, it's roughly 1,000 times bigger. Oh, it's roughly 100 times bigger. Oh, it's roughly 10,000 times smaller. Whatever. They can see it really quickly and easily right from that. How many Earths would it take to equal the mass of Jupiter? Well, roughly 1,000, but let's figure out exactly. So how many Earths can I get out of Jupiter? I'd have to take this, 898 times 10 to the 15, and divide by Earth. What's Earth? 5.970 times 10 to the 12th. And I'll get, well, let me see, I gotta bust out my calculator. So I'm busting out your calculator, 1.898 divided by 5.97. See if I can do it here. So I'm gonna do 1.898 divided by 5.970, and I get 0.3179, so 0.3179 times 10 to the 15th over 10 to the 12th is 10 to the 3rd. Everybody with me on that part? That's a little bit trickier.
Would you
So-
just minus?
I did this part here. Yeah, minus.
Just minus the exponent.
Yep.
When you're dividing.
Yep.
Okay.
So 15 minus 12. 15 is 3 more than 12, so I'm left with 3. And so here I'll show you what I did. We did 1.878 divided by 5.97 equals 0.3179. And then we said that 10 to the 15th over 10 to the 12th is equal to 10 to the 15 minus 12. 10 to the 3rd. So that's where we got those two parts from. And then, let's see, scientific notation, I need to move the decimal place over 1, which means I need to multiply by 10. So, well, first let's put it into regular notation. 10 to the 3rd, I'd move this over 3, it's a lot easier. 1, 2, 3, so I get 317.9. Yeah? Everyone with me on that one? And then if I want to put it back into scientific notation, then I need to move it over twice. So that would be 3.179 times 10 to the 2nd. So those would be my two answers.
Why did you move it over 3 times for what?
10 to the 3rd.
Oh,
Move it over 3 times. Here's my actual number. And then I put it into scientific notation. I want the decimal place after the 3, so I move it over twice to get back to scientific notation. Because this isn't quite scientific notation because the decimal place is in the wrong spot. So it's just kind of our in-between step.
oh.
Okay, so I'm going to pause there for a minute. Let's talk a little bit about your reading. who has actually started reading this so far yet? One person, 2 people? Okay, make sure you read it between now and before Friday. There are 3 questions you need to answer. Let me show you the questions are. Write them down now in case our tutor does not get back in time. Which she will. Can you guys do that okay? Not really? Okay, so, number 1, summarize the central purpose. Just quick summary, just like what's the main idea of it? And maybe give an example that's specific to the article. So I know you've actually read the article and you're not just using what you know about growth mindset already. Does someone follow me? Give me something specific to the article in here. Good? And then think about your personal life. Is there a challenge that maybe you overcome? If not, consider a challenge you're dealing with now. And that can be short. You don't have to go into a lot of detail. But, just spend just a couple minutes writing about a challenge, and maybe briefly consider. You can write as much or as little as you want, but just give me at least something basic. Oh, she's got the handouts right there. And the last one. So go ahead and hand this out. Yeah. If the author's claim about the brain being like the muscle is accurate, what changes would you recommend? What suggestions would you have for me as an instructor? So, answer those things. They can pass them out too, yeah. So, those by Friday. Answer those questions by Friday. All right, that is it.
You want this typed or handwritten?
You're gonna handwrite it on this piece of paper,
Okay.
and you're gonna turn this piece of paper in. So this sheet of paper right here, you're going to write on it, turn that in on Friday. And like I said, be specific, and number 1, reference something specifically in the article so I know you read it. All right, have a good week, couple days. See you guys.